Hey guys, Tomatho here. Are you smart enough to solve a Math Olympiad problem from USA? Here is the problem statement. What is the values of x that satisfy the following equation? 8 to the power of x plus 27 to the power of x over 12 to the power of x plus 18 to the power of x equals to 7 over 6. This question is taken from USA Mathematical Olympiad in 2001. Can you solve it? Here are some hints for this question. As usual, the hints are progressive and the latter hints are closer to the actual answer. Feel free to pause the video at any time if you found inspiration from it. So, the first hint, factorize both the numerator and denominator. Next, when factorized, both the numerator and denominator have common factor. Can you figure out what it is? Third, the common factor is actually 2 to the power of x plus 3 to the power of x. Try to factorize both the numerator and denominator to simplify the equation. So, here comes the solution. To solve this question, we have to manipulate the left-hand side of the fraction by factorizing both the numerator and denominator. So, let's see. For the numerator, notice that 8 to the power of x plus 27 to the power of x is equals to 2 to the power of x to the power of 3 plus 3 to the power of x to the power of 3. For the denominator, is equals to 6 to the power of x times 2 to the power of x plus 3 to the power of x. But how does this help? Well, as you can see here, the numerator and denominator both have relation with 2 to the power of x plus 3 to the power of x. Clearly, the denominator has 2 to the power of x plus 3 to the power of x as its factor. What about the numerator? Well, we can find it out by looking at how we can factorize the sum of cube expression. In general, we can factorize the sum of cube expression as follows. So, if we plug in a equals to 2 to the power of x and b equals to 3 to the power of x, we have as follows. Then, we rewrite the numerator and denominator as what we have. Then from our factorization, we have as follows. Here, we can cancel out the common term 2 to the power of x plus 3 to the power of x. So now it becomes this. Next, we further break down the fraction. Knowing that 6 to the power of x is equals to 2 to the power of x times 3 to the power of x, and then we separate each of the fraction as follows. So we can break down the fraction as follows. Then we can simplify it. And thus, we have 2 to the power of x over 3 to the power of x plus 3 to the power of x over 2 to the power of x equals to 13 over 6. Aha, interesting. Now the equation looks simpler as it was. Next, let us introduce a variable y and assume that y is equals to 2 to the power of x over 3 to the power of x. And so 1 over y is equals to 3 to the power of x over 2 to the power of x. Therefore, we can rewrite it as y plus 1 over y equals to 13 over 6. Next, multiplying both sides by 6y to eliminate the denominator, we get 6y squared plus 6 equals to 13y. And then simplifying it further, it becomes 6y squared minus 13y plus 6 equals to 0. Aha! Now it is a familiar quadratic equation. So factoring the quadratics gives 3y minus 2 times 2y minus 3 is equals to 0. From here, we have two cases. In the first case, 3y minus 2 equals to 0. This gives y equals 2 over 3. And substituting y to its original value, we have x equals 1. And in the next case, 2y minus 3 equals to 0. This gives y equals to 3 over 2. And similarly, substituting back, and we have x equals minus 1. So, final answer is x equals 1 and x equals minus 1. So yeah, we have finally solved this USA Math Olympiad problem. Do you manage to solve the problem? What answer do you get? Let me know in the comment section below. Thank you for watching. Give a thumbs up if you like this video and subscribe to my channel if you would like to see more interesting math video.